Hello, my name is Omar Al Jafri, and today I'm gonna talk about the uses of wood in aircraft industry. Wood was among the first materials used to construct an aircraft. It all began when the Wright brothers built the first powered airplane in 1903. It was the first of its kind to carry a man above the sky, and it was called the Wright Flyer. It was made of a thin, cloth-covered wings attached to what was primarily a wooden structure. At this point in history, wood was the best option for plane construction. Many modifications has been attempted by designers, including a Frenchman named Louis Blériot. With some notable design differences, he built the first successful mono-wing aircraft. Leading up to World War I, stronger engines also allowed designers to develop thicker wings with stronger spars. Many aeroplanes made a print in World War I, such as the famous two-engined Martin MB-1, which is a famous bomber of which just 9 were ever created. Many other remarkable aircrafts were used in air combat. Here's a couple of them. In the late 1930s, in World War II, the British airplane company de Havilland designed and developed a bomber named the Mosquito. They produced thousands of these airplanes, and they were made of spruce, birch plywood, and balsa wood. It was also the first composite structure aircraft. The de Havilland Mosquito used the balsa wood sandwich material in the construction of the fuselage. At that time, the largest seaplane and the largest wooden aircraft was constructed. It was called the Spruce Goose. Its empty weight was 300,000 pounds, with a maximum takeoff weight of 400,000 pounds. The entire airframe, surface structures, and flaps were composed of laminated wood with fabric-covered primary control surfaces. It could also produce 3,000 horsepower at the time, which was fascinating. There are also other famous aircrafts used in World War II, and they are worth mentioning. Well, people nowadays are going to ask, why use wood instead of using metal or composite materials? There are many advantages that made designers at the time use wood instead of metal. Most importantly, wood has a high strength to weight ratio, meaning that it is strong for its weight. Wood also has a good flexibility characteristics, in that it will flex an indefinite number of times without fatiguing and eventually failing as metal does. Also, flexibility enables it to absorb and dampen vibration. Anyone who's ever flown behind a wooden propeller will tell you how smooth it is compared to the same aircraft engine combination driving a metal propeller. Workability in wood is easier than in metals. It means wood is easier to heat treat and shape. One of the most important aspects that made designers pick wood over metals at the time is that it is remarkably cheaper, more abundant as it comes from trees, plus there was a lack of suitable corrosion-resistant materials for all metal aircrafts. However, in World War II, capacities and supplies of quality wood and rapidly increasing structural stresses made wood structures obsolete. It was becoming difficult to get aircraft quality wood in the sizes required for parts such as wings and spars, and with its rarity comes a high price. Take for example the Taylorcraft BC-12D, an American light single-engine aviation monoplane that was built in the late 30s. The front wing spar is 0.75 inches thick, 6 inches wide, and more than 16 feet long. Regulations require that wood edge grain runout be less than 1:15. When parallel to a level surface, the grain doesn't deviate from parallel more than 1 inch over a 15-inch distance. The blank piece of spruce for a spar such as this will cost well over $5 a foot, which is very expensive. The wood should have no knots, grain imperfections, or discoloration that indicates any kind of fungal activity. One reason that made aluminum alloy technology evolve over wood is the need of modern aircraft. This was compounded by wood's past image, traditions, limitations, and folklore. However, the main reason wood lost favor was related to maintenance. There was a lack of adequate quality controls that could be implemented in large-scale manufacturing efforts with mass productions. Also, a lack of a viable moisture protection system for a completed structure was at the heart of the problem. All wooden structures need some reasonable moisture stability to prevent internal stressing and fungus attack. Moisture-related problems persisted in the 1940s, and it limited wood as a viable engineering material. That's why wooden aircraft should be always stored in a covered and well-ventilated hangar, where moisture and contaminants such as birds and dirt cannot reach the wooden surfaces. There are two types of wood that are used in specific aircrafts nowadays. There is solid wood, and it's used for such parts as wing spars, rib cap strips, and fuselage stringers. And there is plywood, which is used for such things as floorboards, wing skins, and gasket plates. And that's about it. Thank you for listening.